exponential functions and tables of values. I can find, after today's lesson, you'll be able to find missing values in your table or extend your table in either direction by using your knowledge of rates of change for an exponential relationship.
For each exponential table below, find the pattern and then find all the missing values in each table. So anytime we have a table, as we've said throughout this whole unit, you need to start with your change in y and your change in x. So please do that now. And again, you're only going to be finding the ones that we know. And because it's exponential, we know that this will have a common multiplier for our differences. At this point, you should see that your change in x is increasing by 1 and your change in y is increasing by a different amount. Normally, when you see this change in y increasing by varied amounts, you'd have to look at, is it quadratic or exponential? We are told this is exponential, so we know that we are looking for a common factor here. And because I'm going from 786 to 192, the magnitude is getting smaller, we are going to be dividing. And so you can take and divide 168 by 192. That gives you 4. We know that our dividing by 4 will work down all of our change in y values, but we need to figure out what those values are. I'm going to put some placeholders in. So there's going to be a change in y in each of these spots. And then we know that this between negative 192 and whatever this change in y is going to be changing by a factor of dividing by 4, as well as between these factors. And we need to know that pattern so that we can predict our y values that are missing. So remember that when you're going down your table, you're dividing. So negative 168 divided by 4 gave me 192. Negative 192 divided by 4 gives me what? You have to divide that on a calculator or divide it in your head or on paper. And that gives us negative 48. And now negative 48 divided by 4 gives us negative 12. And negative 4 divided by 4 gives us negative 3. Working down the table is easier because it goes the way you think it will go. It's more intuitive. Now we have to look at our values here and take our 189. 189 minus 48 gives me 41. 41 minus 12 gives me 29, and 29 minus 3 gives me 26. To talk about our rate of change, we would say that our rate of change is decreasing by a factor of 4. And the decreasing is because of the division, because those values are getting smaller. Let's take a look at number 2, in which you are going to do your change in x and change in y. Again, that's how we start every problem. Be careful when you are writing your changes or your little arrows here, because you want your to keep your work organized as you go through there. Now, obviously, you're only going to have to do the ones that you know, and these spaces here are going to be unknowns that we're going to fill in once we know how our rate of change is behaving. So I can see that my change in x is changing by 1, negative 1 to 0 is increasing by 1, 0 to 1 is increasing by 1, and so on. When I have negative 5 to 15, I'm still seeing some errors on our, so you're at negative 5, which is right here, and you were going to 15, you're going in the positive direction. So if you're starting here and you're going this way, that is in the positive direction, and you're changing by 20 if you counted all of that over and went all the way over here to 15. And then from 15 to 115 is 100, and you're again getting bigger, so it is positive. Now we need to look at our common factor. We're going to increase by a multiplier because we're getting bigger. 20 times what gives you 100? You can also find this by dividing 100 by 20. And that you should see that that is 5. That means all of our change in y's are going to increase by a factor of 5. We could write that here. So these are our rate of change is going to be increasing by a factor of 5, and it's increasing because it's multiplication instead of division. So working down my table, remember, is a little bit easier, I think, because 100 times 5 gives me 500, and 500 times 5 gives me 2,500, and I'm just going to squeeze it in there. Those are all increasing. When I go backwards, normally you're going down the table, so something times 5 gives you 20. Some of you may see that is 4. If you're not seeing that and you have to work back up the table, you could say 20 divided by 5 gives you 4 to find that value. And that is also a positive 4. And again, I like to start working down my table. So now I have 115 plus 500 gives me 615 for my missing value, and 615 plus 2,500, again, you can use a calculator, is 3,115. And up here, something plus 4 gives me -5. Let's look at the number line. You can think about this in a couple of ways. So the point on my number line is -5, and I have to get to -5 from another value, this value right here. And to do that, I'm adding 4. So if I'm adding to get to this number, I need to be coming at it from this angle, which means it's a smaller number. And I need that to be 4 spaces. So I can just kind of think back 4 spaces is here. And if I'm going in this direction, because I'm adding 4, that's going to be -9. The other way to think about this is you're starting at -5 and you think, okay, instead of adding 5, I'm going backwards. So I'm subtracting, instead of adding 4, I'm subtracting 4, and that would still get you here at -9. So it's just the way you think about that to know that -5, and you can always check it, -9 plus 4 gives you -5. Last problem, you're going to do the same process by doing your change in x and your change in y. You can see the change in x is increasing by 1 by each of these values. And you can see between 274 and 97, I'm decreasing by 180, and from 94 to 34, decreasing by 60. We know we need to figure these values out, these other change in y's, based to find our missing parts in our table. And to do that, because we know that this is exponential, we know we have a common multiplier or a common divisor. So from -180 to -60, the 180 to 60 is getting smaller, and so this is going to be a division problem. So we're going to divide -180 by -60, or you can just plug in 180 divided by 60, or even 18 divided by 6. You will get 3. So -180 divided by 3 gives you -60. You're going to continue, because it's exponential, that all of our change in y's are related by the factor of 3, decreasing by a factor of 3. So again, we can write that right here. We are decreasing by a factor of 3. And to continue in our table, we are going to do -60 divided by 3. That gives us -20. Remember, to work up our table, we can do the inverse of division, which is multiplication. Just like when we had subtraction, we can do addition if we're going up the table. So something divided by 3 gives me -180, or I can take -180 and multiply by 3, and you will see that we get -540. And you can check that. -540 divided by 3, yes, that gives you -180. So to get my other value, if I'm going up the table, so instead of dividing like I would normally do if I'm going down the table, it's going to be -540 times 3, which is -1,620. And again, you can check that. -1,620 divided by 3 gives us -540. Now we have to use that information to fill in our table. And so to fill in our table, I like to go down the table. So I would just start with that 34 right here. And 34 minus 20 gives me 814. So that's that bottom value. And then here, normally you're going down the table. Something minus 540 gives you 274. But if I'm going up the table this way, you're going to do the inverse operation. So instead of subtracting, I'm adding. So 274 plus 540 is 814. And again, you can check that. 814 minus 540 should give you 274. Same thing here. I'm going up the table. So instead of subtracting, I'm going to add. And that gives you 2,434. And again, to check that, 2,434 minus 1620 does give you 814. Quick summary here. You can see your table. Your work should look like mine. I want to see those boxes so I can see that you have placeholders there. So working backwards to fill in the change in Y, and then the missing Y values. Use those placeholders to organize your work. That's why I put those boxes in there. And on the practice problems, you may have tables that represent linear, absolute value, quadratic, or exponential functions. So you have to use what you know about those particular rates of change to do work backwards to fill in those blanks.